not x is greater than y. Now you do have to expand pre-1 so that it reads x equals m and y equals n, and then attach x is greater than y to finish the whole thing. And pre-4 is also about the same thing, x equals m and y equals n. And you can simplify if you want to, and not x is greater than y is the same as x is less than or equal to y. So the simplification is up to you. It is optional. I would not take points off if you did not simplify. Do we have any questions at this point? No questions? Now with pre-2 and pre-4 already done, we can deal with either post-2 or post-4. The order is not important in this case. I will just go with post-2 first. Before you explain what post-2 is, you have to decide which rule to use. We already know this is going to have to use the substitution rule, but you have to explain to me why you're using the substitution rule. The usual way to explain that is, I just overwrite some parts of the text here. Okay, so the usual way that I usually do in the class is the right-hand side refers to the left-hand side, which basically means the expression of the right-hand side of the expression of the assignment operation refers to the variable on the left-hand side. But the short form is fine here. Then the next line explains the right-hand side has an inverse. The right-hand side, call it f of x equals x plus 1, has an inverse of f prime of x equals to x minus 1. In other words, you have to indicate to me that it has an inverse and what the inverse is. And since it has an inverse, there's a way to reverse the operation. Then we can apply the substitution rule. So in this case, the application, so we can just say use the substitution rule. And once you use that rule, you can see that it's just a template. Post-2 is the substitution of the result of the substitution of pre-2. What are we finding in pre-2? X, because it is the variable on the left-hand side. And we are replacing it with f prime of x. Okay, just like that. And then you can expand it, because pre-2 is, this is where copy and paste can be a little bit convenient, but even without that, it's not too big of a deal. Just like that. And then you just say, okay, x equals m now becomes x minus 1 equals m. Y equals n does not get changed because it has no references to x. And then the next one is x minus 1 is greater than y. And we are done with post-2. Any questions? And then we will deal with post-4, which is about the same thing, except this time the right-hand side does not refer to the left-hand side on line 4. So the other one, I should say clearly, this is on line 2. And because the right-hand side does not refer to the left-hand side, there's no way for me to undo the operation. If I cannot undo the operation, I have no choice but to use the forget rule, because any relationship that was true before, I cannot guarantee anymore. So now we have to use the forget rule. So post-4 is now the result of forgetting certain things in pre-4. Anything that mentions, in this case, x, I have to forget. Whoops, I think I got it wrong. Yep, I know. I typed over when my focus is on the wrong screen. So we have to replace this with y, because y is the variable on the left-hand side. But after the operation, we also know that y does equal to x after that. So once you expand it, you can see the pre-4 expands to x equals m, y equals n, and x is less than or equal to y. We forget any components that mentions y, but on top of that, we can add y equals to x. And the forget operation will get rid of y equals n, as well as x is less than or equal to y, because both of those refer to y. So as a result, we only keep x equals m, and on top of that, we now know that y equals to x. Is that okay so far? Kind of boring stuff, because at this point it should be fairly mechanical. You see this, you apply this rule, this is what happens, and that's the result. Yep.
Could that not also be simplified a little bit further?
Sorry?
The last statement, couldn't it be simplified to y equals m?
You could say that too. But there's no need to simplify it. This is just fine. If you simplify, that's fine. I won't take any points off, but I won't add any points either. Okay? And then the next thing is easy. Post 5 is the last one. Post 5 equals to post 2 or post 4. Because there are two ways to get to the end, and I don't know which way I came from. And after that, you just do the expansion. And since you guys did not have the option to copy and paste, I would not do that either here. And obviously, there's a whole lot of parentheses to deal with. That's the result. Any questions about the derivation of question number 2? No questions? Okay, moving on to question number 4. Question number 4 is, I don't think it's a whole lot harder than the examples that we went through in the class. We have x gets x minus 1, y gets x minus 1, and we have z gets 2. We know the post condition is z equals 2, and y equals k minus 1, and x equals k. And the question is asking, what do we know about pre-1? Okay, so the question asks about, okay, go ahead and tell me what is pre-3, and then from there, tell me what is pre-2, and then from there, tell me what is pre-1. And you don't have to use the mathematical derivations. You can just try to explain it in words in this case. So we'll go ahead and try to do exactly that. I would say this is approach 1. Approach 1. Because there are two ways to approach this problem. Approach 1 is just starting with post 3. Post 3 is we know z equals 2, y equals k minus 1, and we know x equals to k, I think. Just like that. So what you can do is you can simply explain that line 3 destroys the value of z or overwrites the value of z without any way to reverse the operation. That's all I'm going to ask for, is to indicate that the operation is not undoable, it is irreversible, or there's no way to go back. Okay, any one of those words or other equivalent words would work just fine. So I would just say that since, I used the wrong window again, since line 3 overrides the value of z in an irreversible way, pre-3 is basically the same thing, but I can't really say anything about z anymore, because there's no way for me to reverse the operation and find out what the old value of z was before line 3. Is that okay? And then optionally, you can say post 2 equals pre-3 because they are in a sequence. It is optional. If you miss this part, no problem. I will not take points off. Okay, so now we can look at line 2. Is line 2 reversible or irreversible? Irreversible. It is irreversible because the right-hand side does not refer to the left-hand side. There's no way for me to get an inverse function to reverse the operation. So guess what? You can say the same thing again. Since line 2 overwrites the value of y in an irreversible way, pre-2, we'll basically have to say, oh, well, we have no idea what y was before this, and as a result, we only keep what we knew about x. Are we okay so far? So now you can say post 1 equals pre-2 because they are right next to each other and in a sequence. Just like that. Now what do I say? Is line 1 reversible?
Yeah.
Okay, so you have to say that. Okay, so you have to say since line 1 is reversible, all it does is to subtract 1 from the value of x. Since because of that, we now know that pre1 is going to be x equals to k plus 1. Because when you remove k, if you subtract 1 from k plus 1, then you get k. And that's basically one approach. Okay, one approach is going back step by step and use English to explain why you remove components as you move your way up. There's also a second approach. The second approach is to start with the solution, but then you have to go forward to prove that the solution is the solution. In other words, in approach 2, you can say, I suspect that pre1 is simply saying that x equals to k plus 1. And then use forward derivation to show that post 3 is as specified in the question. So I'm not going to do it, but you guys have an idea of what I mean by that. Yep.
Are you handing the test back?
Yes, I will give it back to you guys once I'm done grading it. This kind of test takes a long time to grade because I have to be looking for partial credit or excuses to give points.
In my case, yes.
But I'll be looking for very specific things, and when I'm all done, when I set the grading scheme, it will be published. In other words, you guys will know exactly, what feature or what part of an answer is worth how many points. So that will be published for the entire class to see. Any other questions about the exam? Was it hard? I mean, was it bad or okay or normal? Okay. Medium? Now, I do have to mention again, what the grading curve looks like. The best way to do it is to use a spreadsheet. Because, I'm pretty sure someone has the question and just, did not want to ask it in the class. So I'm going to talk about it anyway. Okay. So if you look at the percentages, the breakpoints in terms of percentage is 12.5% is one boundary. The next one is 3.375. And then the other two will just be these two numbers. These are the proportions. In other words, someone who's getting less than 12.5% of all the possible points will get an F. Anyone getting between 12.5% and 37.5% will get a D, and so on. So in this case, because the test has exactly 60 points, so that means the actual point value or the boundary of the point values is going to be, in this case, A2, the cell A2, times $1, because we need absolute reference for the row number. And here you have basically a breakdown of the points. Anyone with 52.5 points or more will get an A, in terms of letter grade. Anyone who's getting 37.5 points and 52.5 points will get a B, and so on and so forth.
So if you put your name on the paper, you pass.
No, if you put your name on the paper, at least I know where the points go.
Okay.
Without a name, then it will be a 0.
Yeah.
Especially when there are more than people in the class without a name, then I cannot know.
Right.
I cannot apply the pigeonhole principle anymore.
Right.
Okay. Are there any questions about the grades? No. I personally think it's pretty hard to fail this test, but that's just me.
I don't know. I might have done a pretty good job.